In this guide, I plan to refresh my OPNsense full network build guide. It's been about 2 years since I created the original guide, and I thought it'd be a good time to update that guide so I could show off the latest version of OPNsense, as well as some little things I've learned along the way in the last 2 years. And I plan to use some newer, different network hardware, some of which has been sponsored by Grandstream. I've got some 2.5 and 10 gig switches that I will be using, and I'll be using a slightly different network architecture as well. I'm not going to be making use of lags, which kind of complicates things for new users, especially if you don't really need them. If you have faster network switches, you're less likely to have bottlenecks. But perhaps in a future video, if you want to see how to do that with these network switches, I could show that off. And I've been excited to do this video for a while because things have changed over time, and I know a lot of people are looking forward to just seeing different examples. So I like trying to provide just different ways that you can construct your network using different hardware, because everybody's going to have something different. I get feedback all the time, asking about different things they can use for their networks, and sometimes it can be overwhelming or confusing. And I'm hoping by showing different examples, you can pull together different pieces that you need to help you get your network built the way that you want. Before I get started, I want to mention a disclaimer that the things that I mention in these videos and any of my other videos, it's all in a home network context, and what might be good enough or adequate for home network use for security and other purposes may not necessarily be a good idea in a business or enterprise context. So, where the environment needs to be locked down and maybe restrictive as much as possible because they are a bigger target for, hackers. So I just want to throw that disclaimer out there in case you want to try to do some of the stuff you do at home that you learn maybe perhaps on this channel and you want to do it at work. I just don't want you to go and be like, I saw that on that YouTube channel to do this. And they're like, well, that's not the best idea, right? But I'm hoping for a home network, it's still going to be more secure than having an open flat network. But we're still going to be locking things down, and we're going to still be allowing things to access the network, right, without too much hassle. So that's where I try to balance that. Especially when you have family members, you want to be able to balance security and usability. That's my goal. My goal is to have as much security in place without my family even noticing it. If my family starts noticing the security stuff I have in place, then that means I'm locking things down a little bit too much and I need to tweak it a little bit, right? So you got to rein it back. So sometimes I try things and it gets a little bit frustrating for family members. But that's something just to keep in mind when you're doing this for home networking, not necessarily for a business or enterprise. So let's take a look at the hardware I'm going to be using in this network build guide. And keep in mind, you can use whatever hardware you wish, but you're going to have to adapt the concepts to the hardware that you're using, because I can't show every possible hardware that's available to be used for a home network. So I'm just showing different examples in my videos, and I'll do more in the future as well. So you can just try to pull together different pieces of information that you need to try to construct the network that you like to have at your home. So everybody could have their own home network that meets their needs. Okay. So first of all, in the very back corner, I have a Jet KVM. You'll probably see this in some of the videos. It's going to be used to control my OPNsense box to install OPNsense, as well as the PC that I have that I'm using to manage all of my web interfaces for all my systems. So I'll be using that for 2 different purposes up there, and so that's why I have it in this rack. And up here at the top, I have a Ratza X4. It's a little N100 Raspberry Pi size system, which is very nice for me just to have a simple computer that I can access the web interfaces of these systems. I have a PoE hat on it, so when I plug it into the PoE switch, it's going to get power, so I don't need a separate power cord. And then I have a Tometek TC300-TTG, which is an Intel C3758 CPU, and this system supports ECC RAM, and it's a low power system, it's like 25 watts, something like that. So this makes like a nice little low power Proxmox server. I have 64 gigs of RAM in it, so I can have a lot of services I can run on this little box. And it has like 8 cores, so it's decent little system. And so I also going to be using 2 network switches from Grandstream, as I mentioned earlier. Grandstream sponsored these switches for this video, which I appreciate. It helps me create a little lab network here and show off some of their hardware. And just like Ubiquiti's Unify products, these switches can be managed with a centralized software if you don't want to manage them directly. Each of these devices have their own web interface, which is great, but you can also manage it through their controller software. So it's called the GWN Manager, and I will be running that on the Proxmox system. That's why I have a Proxmox system up here, is so I can actually run that GWN Manager, so I can manage these devices on my network. Okay, so this switch here is the GWN 7821P. It's a PoE++ switch with 2.8, 2.5 gig Ethernet interfaces and 2 SFP plus interfaces for 10 gig. And then I have a 10 gig switch down here, which is a GWN 7832, and it has 12 10 gig Ethernet interfaces, okay? And they're all SFP, so you can use fiber or you can use these DAC cables. I love using these copper DAC cables for short runs because they don't get as hot as fiber cables, and they are a lot cheaper than buying modules and fiber cables, because you have to buy 2 modules for each connection you want to make. Then down here, I just have like a little brush panel because I just have one extra gap here, so I just covered it with this extra brush panel that I had. So I'm not really using that for anything. And I have a modular patch panel here. I forgot to mention that's why I have all these connections coming in from the back, so I can have nice clean connections in the front. And I even opened up one of the holes here in the modular patch panel so I can run a 10 gig SFP plus DAC cable from the OPNsense system. And right here, this 2U system here is a Intel N100 system that I built in a previous video that I said I'd use in a future video for a network build guide, and now is the time to use that. It has a 2.5 gig Ethernet card in it. It has a 10 gig SFP plus card in it, and I'm going to be using the onboard LAN, which is a Realtek chipset, but since I'm going to be using that as the management interface, it seems to work okay. You don't have to worry about Realtek causing problems, since it seems like not all Realtek has problems with FreeBSD and OPNsense. And you can even install the driver for Realtek, which I'll show how to do that. That will potentially give you better compatibility as well. So then down here we just have a PDU, which has all of the power connections, so I can just turn them all on. And so I have it all contained here in a nice 8U rack. It's pretty full. And as you can see, you can have it all contained in a small little bit of space. And finally, I'm going to be using 2 Grandstream wireless access points. I already had one of those access points, and Grandstream sent me another one in a previous video that they sponsored. So I appreciate that, so I can actually test these out. They're going to be right next to each other in this video. It's just for illustration purposes. You normally would not want to have them that close, but I'm just showing an example. If you have them in 2 different locations in your house, say upstairs and downstairs, or one end of the house and the other end of the house, depending on how your house is laid out, and just to show how you would configure multiple wireless access points in this network and with your network switch. And I think it's a good illustration for those that might need more than one access point. Now that I walked through the hardware that we're going to be using, I'm going to show you a logical network diagram so you can see what we're trying to build and achieve. As we walk through this video, I'm going to show each step of the way what connections you need to be plugging in at certain times, because we don't have to have everything plugged in all at once, because I want to plug it in as we're getting ready to configure the devices, just so you know that now this is what we're going to be doing next and what we're configuring. That way we're just on one piece at a time and we're not getting overwhelmed by plugging a bunch of stuff in and trying to have to troubleshoot that, okay? I think it makes it a little bit easier to say, okay, now we're going to configure OPNsense, and then we're going to connect OPNsense to the network switches, and then we're going to connect the PC to the network switches, and then then we're going to connect access points and Proxmox server and that sort of thing, right? So we're going to be walking through each of those steps. So a quick rundown of the steps we're going to be completing in this guide is we're going to install OPNsense, and then we're going to plug the WAN interface of OPNsense into the existing home network, and then we're going to be updating OPNsense, and then we're going to install optional drivers depending on the hardware you're using, such as what I'm using in this rack, and then we're going to configure some basic system settings, and then we'll be setting up the interfaces in OPNsense, which includes the VLANs. And then we'll configure the DHCP services and a little bit of DNS configuration. And then we'll be doing some firewall configuration to finish up the OPNsense configuration. Okay, and then we're going to move over to Proxmox system and using the GWN Manager. I'm going to have all of the hardware of Grandstream adopted into the GWN Manager already, just to speed up this process. But I'll be configuring the network switches. We'll be setting up the VLANs on the network switches and setting up all those interfaces to have the proper VLANs on both network switches. Then we will also configure in the GWN Manager, we'll be configuring the SSIDs for the different VLANs. We're going to create 3 SSIDs so that each SSID can be on a different VLAN, so you can have your wireless devices separated on different VLANs. Having a VLAN per SSID on wireless access points is the easiest way to separate your devices with VLANs. So at the end, I'm going to cover a couple different miscellaneous topics you might want to do, but I didn't want to do them earlier in the video so that I could just keep this moving and get the basic network set up. First thing we need to do is set up OPNsense on this system. We're going to be using the OPNsense VGA image, and we're going to image a thumb drive and put it into the system, and that's how we're going to boot off that. And I like to just set up the LAN and WAN interface through the command line, and then any additional interfaces I want to set up, I just do it through the web interface so I can configure all the VLANs and everything I want to do, and then I'll log into the web interface and we'll continue the configuration from that point on. If you go to the OPNsense.org website, on their download page, you can see where you can download the various image types. The default VGA is fine, but they have other options. The VGA is good for just a USB thumb drive, and you can pick a mirror that's the closest location to where you are at so that you can get the fastest download speeds. So now we're booting the OPNsense installer. When you see the configuration importer, just let it go. Don't hit any key. Alright, when you see the manual interface assignment, press any key. We don't want to configure any lags, no VLANs. And you'll see all the interfaces that you have available. You'll see IGC0, which is our 2.5 gig Ethernet interface, and RE0, which is our Realtek gigabit Ethernet interface. So for the WAN, we're going to use IGC0 for the 2.5 gig interface. And for the LAN interface, we're going to do RE0 for the Realtek. If you're using different hardware, your interface names will be different. And we'll skip the optional interface because we're going to enable our 10 gig interface later because it's not enabled by default. So yes to proceed. Right, for the login, you type installer so we can install this OPNsense. And then for the password, we do OPNsense is the password. That will open the installer. And we'll continue with the default key map. And then we're going to install ZFS. That's what I recommend doing so you can take advantage of snapshots. And you're going to see that the Z route's already taken because I've already had a demo installation installed here. And so you may not see this screen if you're using a blank disk. So we'll hit OK. And I'm going to be using a stripe because I only have one disk in here that I'm going to be using. But you could do a mirror or any other RAID configurations that ZFS offers, which is another advantage of using ZFS. You can have a lot of redundancy here if you want on your firewall. So let's hit OK. And I'm going to be using the first disk, ADA0. And you can pick whichever disk you want. You just hit the space bar to select it. And if you need to do more than one, you just go down and hit both. And you hit the space bar key. But then just hit tab and it'll take you down to the OK or back button and then hit enter. And then it says, are you sure you want to destroy the disks? And hit yes. And now it's going to be installing the system. We'll just wait for this to finish and then we will continue on. Alright, so now that the installation's finished, we can change the root password before we even get started, which I recommend doing. So let's enter that. Alright, so now we can hit complete install and we can confirm and exit. So we can reboot the system now. And at this point you want to take out your thumb drive to make sure it doesn't boot back up to the thumb drive. Alright, so now OPNsense is booting up. So now that we have OPNsense booted up, you'll be taken to the login prompt. At this point, we should be able to log into the web interface, but I'm going to describe the connections you need to do next so that we can get into the web interface. First, we'll plug the 2.5 gig interface into the existing network for the WAN connection. Next, we'll plug the DAC cable into the 10 gigabit SFP Plus interface on the back of the OPNsense box. Then we'll connect the Ethernet cable to the motherboard Ethernet connection for the LAN network. Moving to the front side of the system, I have the LAN connection connected to the patch panel, which will connect to the network switch. Next, I'm going to route the DAC cable from the back of the system to the 10 gigabit network switch. I'm going to connect the two network switches together with another short DAC cable on the front here. That will link the two switches together. Then I'm going to connect an Ethernet cable to the back of the PC. Then I'm going to connect the PC, which is routed to this patch panel, to the network switch. Our network switches are not configured at this point, so everything is on VLAN 1, which is the default untagged network. Okay, so that way our web interface is going to be easy to access, so we're going to be doing that next. So we're going to log into OPNsense using 192.168.1.1, or you can use the host name like OPNsense. So let's log in with the root user and the password that you set. So now that we logged into the web interface, we'll be able to get the latest version of 25.1, and that way we just start off with the latest version, most current version of OPNsense before we do anything else. When you first will log in, you're going to see the wizard here that you can go through the wizard to set up OPNsense, but we're going to just click on OPNsense because we're going to just do a couple different steps here first. It doesn't really matter if you go through those steps because you can find it where to set the settings at through the different menus, and I'd rather just show it that way so you can kind of see where they're located at, so you'll know where to go when you need to change something in the future. So I have my WAN interface connected to my lab network, which is on a different VLAN, which is why it's 192.168.110.1, and you can connect this to your existing network if it has the same IP address as your LAN interface so that you can update OPNsense, but you're not going to be able to access the internet from the LAN interface behind a secondary router because it's going to conflict with your gateway of your WAN interface because it has the same IP address as the interface IP address for the LAN interface. All right, so we're going to go to System, Firmware, Status, and then we're going to click Check for updates. All right, so you see here there's a new version available that we need to update here, 25.1.2. So let's go ahead and hit update, and we're going to do this before we continue. All right, so now we rebooted the system, so let's sign back in. So now at this point, we can install the optional drivers for Realtek just to make sure we don't have any problems with the Realtek interface. I mean, the fact that we can access the interface and OPNsense recognizes it is a good indicator. We're probably going to be okay with the default drivers, but generally it's recommended to install the plugin to make sure you have the latest supported drivers from Realtek for FreeBSD, which is what OPNsense runs on. And so we'll do that, and we also are going to enable the Molinex ConnectX driver because I have a Molinex ConnectX 3 network card in there for a 10 gig interface. So now we're going to install the Realtek driver, so let's go to System, Firmware, Plugins. We're going to install Realtek. You can see this driver here. So now we have Realtek installed. To enable the Molinex ConnectX 3 driver, let's go to System, Settings, Tunables, and then we'll drop down to Add, right here at the bottom, and we'll type in MLX 4 EN underscore load, and then the value, we just enter yes, and then you click Save. Then you click Apply. Then you want to reboot the system and click Yes. All right, so now we need to log in since it's rebooted. This is the root user here. If we go to Interfaces and Assignments, you'll see we now have a Molinex device here, which is great because that's what we need in order to be able to add VLANs to that interface. So now we're going to tweak a couple of the basic system settings to get started, and then I'll show some more settings that we can do later in this video. So I'm going to update a couple of the basic system settings, and I'll circle back around later as I mentioned, and we'll do some more settings. But I want to show you in the system settings general that we're going to change the host name to router. I'm going to call it router demo, but you can just call it router or whatever you prefer for the host name. And then you can use a host name you own, like I own homenetworkguy.com. But you could use any domain name that you like, especially if you own that domain already. You just got to make sure it doesn't conflict with a real domain name, because this will be the domain name that you use on your local network. If you have any web services or apps that you want to set up, it's going to use this domain name. DHCP is going to hand out this domain name, and router demo is how you can access, your router by host name. And we're also going to change the theme to dark, just to make it easier on your guys' eyes, because I know some guys prefer dark mode. So OPNsense has a built-in dark theme, but I don't like it quite as well as like the, I think it's called Cicada. And that one is, I think, has a little bit less contrast and looks nicer, but it doesn't have the new OPNsense logo, which they changed in 25.1. So, if you care about that, then it's not going to have that new logo. But so down here at the bottom, there are some DNS server options. These are settings for the OPNsense system itself, because notice we're in the system settings. This is OPNsense, not necessary for all devices on your network. So you can allow OPNsense itself to use your DNS server list or not from your WAN, which means if you have DHCP enabled for your WAN interface, it's going to use your ISP's DNS servers for OPNsense to do like updates and those sorts of things. If you don't want OPNsense to be using your DNS servers on your WAN connection, you can uncheck this box so that you can use, like, say, a DNS over TLS or some other configuration. But I'm going to leave this checked in my video because I'm connected to my existing network. So I want to have this enabled so I can get the DNS server from my WAN interface. So this is something to keep in mind. A lot of times on my actual network, I uncheck this so that way I run everything through DNS over TLS. And then let's click save. Oh, so now we got dark mode. This should be a little bit hopefully easier on your guys' eyes as you watch this video. So next we need to configure the interfaces. I like to use the default LAN as my management network because everything defaults to that, so it makes it easy just to access all of your management interfaces, and you don't have to write any VLAN configuration getting in the way. But I know that's not a good practice, especially in business and enterprise environments, because you want to have all your management interfaces on its own VLAN. For a home network, it's a small network. It's easy enough to make sure all your other devices are assigned to different VLANs. That's why I always just dedicate the untagged for management, and then I make sure all my other interfaces on my network switches are assigned some sort of VLAN. So even the unused ports I usually put it on like the guest VLAN. So that way if somebody plugs into a random port in my house on anywhere, they're just going to be on the guest network. They're not going to be on my management network. My network's small enough, it's easy for me to keep things off of that management network. Okay, so now we're going to work on the interface settings. So let's go over to interfaces, and we're going to go on the WAN interface, and let's get this set up. So we can go ahead and check this prevent interface removal. This kind of just removes that trash can icon on the interfaces page so that you don't accidentally delete the interface, but it's going to warn you before you do that. So it's kind of hard to accidentally do it, but it's just one little extra protection there. Just make sure you don't delete an important critical interface. All right, so if you have this OPNsense box behind another router and it has private IP addresses, you can uncheck these two boxes for block private networks and block bogon networks. And especially if you want to access something behind your second router from your first router, because it's going to not allow that traffic through the WAN interface. But if this is your primary router and it's on the edge of your network, and your router is getting a public IP address on the WAN interface, you want to leave these checked by default. That's why they're checked like this, is an extra protection. In this example, I'm going to assume your ISP gives out DHCP and DHCP v6 for your WAN IP addresses for your network. We're going to scroll down to here in this DHCP client configuration. This is for IPv4, even though it doesn't say v4 up there. In this section, you might want to use reject leases from 192.168.100.1, for example, if you know what your modem IP address is, if you're using, say, a cable modem, because sometimes if your modem loses internet connection, your WAN interface will get assigned this address, probably for diagnostic purposes, to access your modem's web interface when your internet is down. So if you want to prevent that from happening, you can block that lease in here because sometimes it won't reassign your WAN interface the public IP address and you won't be able to get access to the internet. I know I've had this problem occur before and I didn't understand why it was happening, but then I saw this explained somewhere where that could be an important thing you might want to do. So let's go down to DHCP v6 because there actually is some configuration we need to change here. I'm going to assume your internet provider is going to be handing out prefix delegations that are larger than /64 because that's the smallest prefix delegation size. If your ISP only hands out /64, that means you can only have one internal network that has IPv6 in it because you're not supposed to divide up the second portion of IPv6 address, only the first half. And so my ISP does /60, but because, as I mentioned earlier, I divided up part of my prefix delegation just for my lab network, I made it /62 so I can give me the last 4 subnet addresses from that prefix that I'm allocated for IPv6. So you might want to probably use /60 or /56. That's usually the common ones that ISPs hand out. But I'm only using 62 just because I'm further dividing it up for the subrouter. So I just want to make note of that so you don't get confused on the delegation size of why mine's a little bit different. Okay. And you can do this send prefix hint. That's something it doesn't hurt to do because some ISPs might need that prefix hint so you know what, so you can request what prefix delegation size that you want. It doesn't mean you'll get it, but it sometimes will help, especially if the internet provider allows you to pick different ones. This will kind of give it some idea what size prefix you want. All right, so we'll just click Save and Apply Changes. Now, what we can do, we could go over to the Overview page and go to the magnifying glass here where it says Details. So we'll scroll down to where you see Dynamic IPv6 Prefix Received, and you'll see that I actually got my /62 that I was looking for. So that's great because that means I got the proper prefix, and that means we can assign all of our other VLANs different subnet addresses of IPv6 with the prefix delegations that we have, and we can give them different network addresses. So we'll close that out, and let's go to the LAN interface, and we're also going to do prevent interface removal. And we're going to have this on track interface. It might be set like that by default. Also on the track IPv6 interface, you want to make sure this is track interface at the top, and at the bottom the parent interface is going to be the WAN. And we want to change this assign prefix ID. You may or may not need to change this. If you're on the edge of your network, usually your router gets a different IP address, IPv6 address that's not in the same range that you are allocated to use with your internal network. So 0 will work fine for the LAN interface, but because I'm behind a subrouter, if I pick 0 for this, it's going to pick the same IPv6 range as my WAN interface is on, and I don't want to do that. So for my use case, I'm going to put 1 here, and this is in hexadecimal. That's why it says 0x. You just got to keep that in mind. It goes 0 through 9, and then after that goes A, B, C, D, E, F to go from 0 to 15, which means 16 different networks. So we're going to allow manual adjustment DHCP v6 and router advertisements because there's some settings in there we might want to change. So let's click Save. We'll click Apply Changes. So next we're going to be creating VLANs, and those interfaces are all going to be associated to the 10 gig interface. So we have the fastest interface, and because it's 10 gigabit, it should be able to handle that extra throughput routing between networks beyond 1 gigabit if you need it. So what we're going to do now, we're going to go over to devices. They changed the menu name in OPNsense 25.1. It used to be called other types, I believe, but now they moved all this stuff under devices because they're considered different types of network devices, even though they might be virtual. Like this VLAN, this is like a virtual device, so that's why they kind of lump it under this category of devices, which makes sense. That's why a lot of terminology of routers use that, so I like that they renamed this for clarity, so you know where these interfaces are located. So let's go over to Add, and we're going to create 3 VLANs. We're going to do a user VLAN for all your workstations, PCs, laptops, those sorts of devices. Then we're going to create a guest network for guests, and we're going to create an IoT network for all your IoT devices. So it's pretty self-explanatory what we're going to be using them for. So we're going to always leave this device empty or blank up here because it will auto-generate a name. As you see, it says leave it empty to generate a device name. It says custom names are possible, but it only if it matches certain things, and so it's better just to leave it automatic. So we're going to pick the parent interface. We're going to use our 10 gig interface for all of our VLANs, so it has the maximum throughput, and we're going to use VLAN tag of 10. And we'll just leave the priority here the same. Priority doesn't matter unless you're going to make use of quality of service controls, which is a more advanced topic you can dive into. I haven't really done it myself too much, so you don't have to worry about that. So let's call this user for all your user devices here. You could also consider this maybe your trusted network, trusted users network as well if you want. Let's click add for the second one. And then we got to make sure we're picking the proper physical interface, the 10 gig interface. VLAN tag of 20, and we're going to call this guest. Right, and hit save, and do one more. We're going to pick Molinex, and then 30 VLAN, and then IoT. So I want to keep it simple. Let's do 3 VLANs. You can create as many as you want or as few as you want. We'll click apply. All right, so let's go over to the assignments. You'll see the Molinex, this is the physical parent interface. This does not have VLANs, it's just the untagged interface. But then you'll see the 3 VLANs that the parent is that physical interface. So we're going to assign these 3 interfaces. So we have our VLANs. And I'm going to just call it the same as the name of the VLAN, which is user. I think it's going to call it that. Yep. That's another thing that's different than in the past. It automatically fills it in with the name of this interface. It used to be you had to type it in. I like that they kind of save time like that, because I end up doing that a lot where I just name them the same so they all match. Okay, so we'll just hit add for each one of these. So we're just adding all 3 of these so they all show up here. And then we just need to go to each one and configure them. We'll just start with the user one, which is our first VLAN interface. So what we're going to do is we're going to click on enable interface and prevent interface removal. Then for IPv4, we'll do static IPv4, and for IPv6, we'll do track interface. Remember, track interface is used just for dynamic IPv6. If you have a static IPv6 assigned to your ISP, consider yourself lucky, first of all. And second of all, you could just go in and do static IPv6 and be able to configure your IPv6 ranges directly, which would be very similar to how you assign your internal addresses for IPv4. So I wish I had static IP, but I don't. Most users seem like they don't from their ISPs, so we'll just use track interface. And we're going to go down to IPv4. We're going to use the network address of 192.168.10.1. Make sure we change 32 to /24. And then for track IPv6 interface, it's going to be the WAN, of course. Remember, we assigned the LAN interface prefix ID 1. So we're going to do prefix ID 2. All we have is 1, 2, and 3 because we can't use 0 because we have 4 networks assigned to my lab network. And then hit allow manual adjustment of DHCP v6. Then we can go ahead and hit apply changes. And then I'm going to go to the guest network and we're going to do enable interface, prevent interface removal. This is all the same pattern, right? A static IPv6. Since I only have 4 prefix IDs that I can use and I can't use 0, that means I can only use 1, 2, and 3. I'm going to skip doing IPv6 on, let's say, the guest network interface because I only have 3 that I can assign, and the LAN plus the 3 VLANs means I need 4, but I don't have those available. But I want to be able to show you enabling this on the IT network because it's going to be more important to have IPv6 if we're using Matter, for example, for smart home devices. We're going to make this one 192.168.20.1/24. Okay, then hit save and apply. You could wait till the end after you configure all your interfaces to apply, but I'm just doing it as I go. It doesn't hurt anything. Okay, so if we go to IoT, we're going to enable interface, prevent interface removal, IPv6, actually IPv4 I mean, and then we're going to do track interface on this. So we're going to scroll down to here, IPv4, and do 192.168.30.1. I like just to keep them similar to the VLAN tag as my network address there because it's kind of easy to keep track of it for me. And then parent interface, we got WAN. Okay, for the prefix ID, we use 1 for LAN, 2 for user, and we'll use 3 for the IoT network. Okay, because that's our last one we can use. So let's go to manual adjustment, DHCP v6 and router adjustments. We'll hit save. I'll click apply changes. So next up we need to configure DHCP, and I'm going to be sticking with ISC DHCP because it's still the default in OPNsense 25.1. So I'm sticking with the default of OPNsense. Kia is not fully mature. It's the new version that ISC has produced. ISC DHCP is the original version they produced. And it's getting harder for them to maintain that. So they decided to create Kia. And it might be a slow, long road before Kia becomes like the standard. What we're going to do now is configure the DHCP services. We're going to start with DHCP v4. And as I mentioned earlier, we're going to use ISC, which is the default. And let's go to LAN. You'll notice the LAN interface is already set up with this range here, 100.100 to .199. Remember, you can change this if you want. You can go all the way from .2 because you can't use .1. It says available range is 1, but that's what your interface is. So you have really .2 to .254 is your full range here. It's nice that they display this for you so you can know how big of a range you can put in here. Especially if you're using a larger subnet, it's helpful to have that. One thing to note about this DNS servers option is if you are running a DNS server on your network that's separate from your OPNsense, you're not using Unbound DNS or you're using that upstream or whatever, you can put the IP address of, say, Pi-hole in here, primary and secondary, if you have two of them running. And it gives you a way to provide your DHCP clients on your network, your DNS servers, so that they know how to resolve IP addresses. If we scroll down to the bottom, you can see that you can add DHCP static mappings for this interface. You can hit this plus button and you can add in your static IPs. I recommend just going to the leases page. It's the easiest way to do it. And then you can go in here and just click plus on any of these and it automatically fills in your MAC address, so you don't have to copy paste that and figure out what your MAC address is. It's already there. So I like doing DHCP static reservations from there. It's just one thing I want to show real quick before moving on. So let's go to the user network and we're just going to enable DHCP server and we're just going to make the range similar to what the LAN interface is. You can adjust these accordingly for your network, but we'll just make it this consistent just for this example. And we'll just hit save. And then we'll go to the IoT network and we'll do the same thing. I'm just kind of copy paste this just to make it a little quicker. It's not the type because I can say 100, paste and do 100 to 199. And then we'll hit save. And then we'll go up to the guest network, click enable, copy paste this, 100, 199. Okay. Setting up DHCP is pretty simple if you're just doing something basic like that. All right, so now we're going to go to ISC DHCP v6, and remember only 3 of our 4 interfaces have IPv6, just because I'm ran out of prefixes I can delegate, but you should have more here depending on how many prefixes you have delegated and how many VLANs you've created. So let's go to the user interface here and we'll hit enable. And for the range here, you have a wide range that you can do, and just to kind of keep it similar to IPv6, you can do something similar like, so you can do like 2 colons and then say 1000 to 2000. So you can specify whatever range is a valid range here. This gives you 1000 addresses for IPv6. So that should be pretty, plenty even with an IoT network. But one thing to note, so you have a dynamic IPv6 address as we have up here. All you need to do is enter the second half of that. And the way you do that is you do colon, and then you do 1000 to whatever range, right? So you do the double colon, and that indicates you're just only specifying the second half. If you're using static IPv6 addresses, you would just enter your whole IPv6 range, the start to finish, just like you do with anything else. It's all pretty simple when everything's static, right? You just have to carve it out yourself. You don't have to worry about prefix delegation range, but just as a sneak peek of potential future content, this is how you can delegate a prefix to pass down to a subrouter. And that actually tells you that in here. So this is where you'd make use of what I did to get extra IPv6 addresses carved out for me for my lab network, so I can actually use it for my demos here. And we'll just click save. So this is going to be very similar to how we did IPv4. So we'll say enable, and we'll just do double colon 1000, double colon 2000. All right, we're just going to do this on all the interfaces for IPv6. I'm gonna make sure we enable it first. It's easy to forget. Sometimes I do that and I'm like, why is nothing getting assigned IP addresses? So you gotta make sure you enable it. So scroll down, hit save. And that's all you have to do to enable DHCP. As you can see, it's pretty simple once you have your interfaces set up. You just have to specify your ranges basically on all these interfaces and then click enable, and then you're good to go. All right, so what we're going to do now is go down to router advertisements, and we're going to configure this for each interface. We'll just start with IoT this time. We'll just work our way down because it's going to be the same for each of these interfaces, pretty similar to how we configure all the other DHCP services. So we want to enable router advertisements, which there's various options here. If you only want to use DHCP v6 and not Slack, you want to just pick managed. Or if you want to allow both DHCP v6 and Slack addresses to be assigned, you can use assisted. And that's probably what I'd recommend, because there are some clients that don't support DHCP v6 very well, but that's probably more so legacy clients. But there could just still be some modern clients that they don't care about IPv6 very much. Devices that don't support DHCP v6 very well can typically get an address via Slack IPv6, so that might be a way you can get more devices to use IPv6. I've seen it mentioned in the past that certain Android devices, older ones especially, that support DHCP v6 very well, so you needed to enable assisted so you can get an IPv6 via Slack. So that's one reason why you might want to do that. So down here we have DNS options. Typically I leave things at the default settings unless I have a good reason or know why I'm changing a value the way that I am. That's why I try to explain it in my videos and written content, why you're changing certain settings, because you may or may not want to do it depending on your situation. But I'm just going to explain what I've encountered, just real world experience and just playing around with stuff and things I've learned over the years. But this is one option that I recently tweaked on my network because I discovered it was causing a problem in a very specific scenario. And I want to mention it as something you might want to do, because it seems like if I enable it, it doesn't hurt anything on other parts of my network. But I just want to caveat that if you are running into trouble, you may or may not want to do this, okay? And that's something you might have to experiment with a little bit, because IPv6, on certain devices and certain software just can be finicky if the support's not very good for it, right? One thing I might recommend changing, because this is what I do on my network because I encounter problems with it, is do not send any DNS configuration to clients. That sounds counterintuitive, but I've noticed it still was getting DNS information to the clients. So I don't know if this just means via DHCP v6 and perhaps through the router advertisements or whatever, it's still able to get DNS IPv6 configuration, because I've tested it out on my other clients and it can still access things via the DNS server over IPv6. So the case that I had where this is causing a problem was I had on the Apple TV, I was using the Amazon Prime Video app, and I noticed when I enabled IPv6 and left it at the default settings that with this unchecked, that it assigned the IPv6 DNS server as the primary DNS server. It didn't seem to affect any other apps, but on the Prime Video app, it must be using that DNS server and possibly trying to connect to all the services via IPv6. So when I go to my settings on my Apple TV, I don't see any IPv6 addresses except for the DNS server. So for some reason, even though I know the DNS server works, it was causing a problem where it couldn't access anything on Amazon Prime, and it just failed as soon as I opened up the app. And I noticed if I checked this box here that the Apple TV still got the IPv6 DNS server, but it put it as the secondary DNS server instead of the primary, and the IPv4 DNS server was the primary. And because of that, it seems like Amazon Prime app works just fine, and it doesn't interfere with anything else. A very specific use case, and it was driving me nuts because I want to have IPv6 on my IoT network because, if I want to do Matter devices, you have to have IPv6. So I need to get that working. And I don't want to make cause problems with other devices, right? So that's one reason why I had to dig into it a little bit further and found that this is something that was helpful for me, even though I'm not 100% sure exactly why. I just know what the effect of it was on the Apple TV. So that's something you might need to play with some of these settings here if you're having some problems with DNS with IPv6. I just want to show real quick that I'm getting an IPv6 DNS server assigned, even though I have the option checked right here that says do not send any DNS configuration to clients. So since I'm on a Linux machine, I can say resolve CTL status, and you can see that I have a IPv4 DNS server, and I also have an IPv6 as a secondary or as one of the optional servers here. So you can see I'm still getting a IPv6 DNS server. So now we're going to go to Unbound DNS, and we're going to take a look at some of these settings in here that you might want to change. By default, it's going to be port 53, that's DNS, and it's going to list on all interfaces by default. You can enable DNSSEC support if you want, if you know that your upstream servers that you're going to be using supports it. Like say if you're using Cloudflare or some other service, you can just click this box here and check that that's enabled. I'm not going to do it currently just because I'm just upstreaming to my local network. So when you come down here to this register ISC DHCP v4 leases, this is where it's going to register DNS names for all your dynamic clients that get IP addresses from DHCP. So this is helpful on home networks when you want, host names to automatically, be usable on your network without having to manually, specify entries on your DNS overrides or whatever, right? So sometimes this is helpful. Some people don't like to enable this because it could potentially be a security issue. Because if you get a new client on your network that has the same host name, now that host name has 2 IP addresses, so it could be confusing or interfere with when you try to access something with that host name. It might use the wrong one or try both or whatever, right? So you got to probably exercise a little bit of caution with this, but in home networks it's probably okay to click this. This will probably be more useful than it is detrimental, I imagine, on a home network. Just keep it in mind for a business network, you probably don't want to do this. You probably want to control this a little bit more of your host names that are on your network, especially for servers and those sorts of things. You probably want to protect those kinds of things. There's probably other ways to handle that as well. So down here is register DHCP static mappings. This one is similar to the one above, except this will register all of your static mappings that you have, static reservations for DHCP, where you can manually specify a static IP on OPNsense for all your clients. And if you do this, it's going to automatically create a DNS hostname for it, which it's very helpful. I like that because especially when most of my static mappings are usually devices or services or apps that I want to access somewhere else on my network, and I want to create firewall rules for them. I always like using static mappings for that to make sure that I'm hitting the same consistent IP address, the same system, and I'm not, I like that deterministic behavior of being able to map all that stuff out just to make sure I can poke holes in the firewall and things don't change on me, okay? Because I know you can use host names, but I've had issues with that in the past, so it's good just to kind of have this enabled for that reason. Now for this option here where it says do not register system A/quad A records, by default, OPNsense registers all the IP addresses of every interface on your OPNsense box to the router's host name. So if you do a host name lookup, you're going to see all the IP addresses for all those interfaces. Some users don't like to register those DNS records because it potentially exposes those IP addresses on all those interfaces to make them easier to discover. Another use for this would be, let's say you have your management interface on 192.168.1.1, and that's the only IP address you want to allow access to your management interface. And say you have a PC on the 192.168.20.1 network, and it's on VLAN 20, and you allow a firewall rule to access that interface. If you leave this as it is, it's going to have all the IP addresses of all the interfaces. And by default, when you try to access your router's host name, it's going to use your local network's interface IP first. It just kind of defaults to that because it wants to go local first, right? So if you check this box and then only specify 192.168.1.1 as your router's host name, then whenever you go to look up that host name to use it to access the OPNsense web management interface, it will go directly to your management interface because there's no other IPs in that host name. So that's kind of an interesting way of working around that issue. I like to have flush DNS cache during reload and set because anytime I'm restarting Unbound or whatever, I want to make sure that DNS cache is flushed because I make enough changes on my network. It's nice for it to be a little more cleared out because sometimes I still have to come in here and I just restart every now and then if I want something to take effect more immediately and not wait for it to cache to time out. So we'll hit apply. So next up, we need to create firewall rules because the interfaces by default don't have any firewall rules assigned. So that means everything's going to be blocked by default. So we're going to also change the LAN interface to be consistent with these other VLAN interfaces as well. So it's a little bit more restrictive and a little more locked down, so we can have all the different networks isolated from each other. And the way I'm going to be doing the firewall rules in this video is a little bit different. And the reason is because I'm going to be showing how to configure IPv6 when you have dynamic prefixes, where the first portion of your IPv6 address could change because your ISP doesn't give you a static IPv6 address. And if you want to make use of the GUAs, which is the global unique addresses, which are publicly assigned addresses, but not publicly accessible, okay? So your ISP will assign the addresses, but the firewall of OPNsense is going to be blocking incoming requests by default. So you're still protected, even though it's a public IP address. It's just publicly assigned, but not publicly accessible, okay? So that's where people are always afraid of using public addresses internally. And that's where IPv6 differs, because they kind of discourage you from using EULAs, which is the user local addresses. I know some people like to use those, but it seems like that EULAs are kind of sort of discouraged because everybody's supposed to be using GUAs. So that's what I'm going to be trying to do in this video, right? Using the global unique addresses. And so I found one way you could potentially work around this, because you can create dynamic IPv6 addresses for hosts if you have like a static, an internal static IP host where the second half of your address is, you set a static portion of that second half of your address, but the first half can change. OPNsense has a dynamic IPv6 alias you can create, which is nice because it automatically figures out what the first half is supposed to be based on the interface that you're tracking, okay, or that you're assigned to, okay? But they don't have a similar concept for if you want to create a network address, which is what I wish they had one, but I think it's complicated to do that, where all I care about is I want the network address range of like /60, but you can't create an alias like that where the first half could change, and I just want /60 to say this is all of my delegated prefix of IPv6 network address space. I want to have that and use that as this is my internal network address ranges, right? So since OPNsense doesn't have that concept, you can make use of firewall groups and kind of achieve something similar. You add all the interfaces, your internal interfaces, to a firewall group, and it automatically creates a firewall group net address that has all of your network addresses in it. So IPv4 and v6. So we can use that auto-generated alias to isolate our networks. And I'll explain this as we go along. This is one consequence of having a dynamic IPv6. This is why IPv6 sometimes it's just a pain to do. And like sometimes I was like, I don't want to turn off IPv6. That's supposed to be the future. I'm just trying to figure out how to use it and learn about it. And I'm trying to show you guys, because some people are like, if you don't include IPv6 in 2025 in your guides, then you're not showing the future. In order to show IPv6 in this demonstration, I had to figure out how to get my primary OPNsense router to delegate a portion of the IPv6 space that I am assigned from my ISP so I can do it to a sub router, which would be this secondary router here. And it's kind of interesting. I'll probably do a guide on that as well, because it's kind of interesting to see how that works. But I only have /60 from my internet provider, Comcast Xfinity. Some people say the spec says everybody should get /56, and I kind of wish that was the case, because I can only get 16 networks with /60, and I'm using like 10 or 11 on my home network, which is kind of a lot, but I like separating things out by function in their own little networks. But I allocated the last 4 of those 16 for this network. I just wanted to explain I configured my primary router to hand out additional IPv6 addresses for this router. That way I can actually show IPv6 configuration. So now we're going to jump over to the firewall rules. As I mentioned, there's several different approaches you can take. I'm just going to show one approach. And there's some other ones I've done in the past and also on my website as well. So you can check those out. Also, and there's probably going to be examples on the internet that people do things even different than the examples I've shown. So one thing that we want to do, our goal for this section, is we want to have all of our VLAN networks isolated from each other, meaning we can't access devices in each of the networks that we have created, because that's the whole purpose for us to set up VLANs. It's not to just separate the broadcast domains, which is great if you have a lot of devices, so you don't flood the network with a bunch of traffic, right? But we also want to build our network so we can kind of separate each different portion of our network for security reasons, like say IoT on its own network, right? And all your management critical network infrastructure on its own network, and and continue on and on from there, right? And then we want our guests to have their own area, right? So one way we can do this is we want to block all private IP addresses on each of our interfaces so that by default nothing can communicate with each other, but we will allow access to the internet. So each of the networks can access the internet, but not any other local networks, okay? So that way they're isolated from each other, and from their perspective, it just looks like they just have access to the internet with just a single network, but we know better than that, right? We know we have multiple networks, and we're just going to limit as much access as we can as we go along, okay? So let's go to Firewall. We're going to go to Aliases. Aliases is a way we can group together a bunch of IP addresses and other things so that we can make our firewall rules more readable, but also we don't have to create as many of them, which is great. Instead of creating 3 firewall rules, we can create one with 3 different networks in it, right? With creating an alias. So let's go to click on this add button, and we're going to create this name called private networks, and we'll click on networks because we're going to add multiple networks. And this is, I copy pasted in the 3 private network ranges: 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16. If all of you are concerned with is IPv4 on your network, this is all you would need. But since I'm showing IPv6, I'm going to also include the IPv6 address in here. All right, and so I pasted in the IPv6 address range. I'm using /62 because that's the prefix delegation I have for this network. Yours will be /56 or 60, or some people even said they have /48, which is pretty large. So this would include all IPv4 and IPv6 addresses that we're considering our local networks, and that's all you need to put in here. And we could just say, all private IP addresses. And we're just treating IPv6 as private addresses, even though technically they're publicly addressable. And and so, but for our purposes, we're using them on our internal networks, right? So we could say all IPv6 addresses, and so you can just create that and then hit apply if you want. So that would work, except what happens if your IPv6 address changes? So if I go here, I have to go back here, and I have to go in here and update this every time my IPv6 address changes. So that's not a very efficient way to do this. If this changes, then you're going to end up allowing access to all your entire network for IPv6. So you're going to have a security hole, right? Since your IPv6 address changes, now you no longer have isolated IPv6 networks. And so an alternative that I thought of, and I've seen others suggested as well, is you can go in and create a firewall group. So if you go to Firewall and go to Groups, and we'll go to Add. So let's give it a name such as Private. And I think this will be a pretty good name for our private networks, because you'll see once it shows up in the firewall rules, because it's going to create an auto-generated alias called Private Net, similar to other interfaces such as LAN Net and usernet and all those sorts of things. So this will be nice because it'll be more readable in our firewall rules if you make something a name such as that. So for the members, we need to select all of our local network members. Make sure you don't pick WAN, but pick LAN, user, guest, IoT. And here you can say no GUI groups. And this means over here on the interfaces section, I'll show you in a little bit, but it'll group all your private networks under a group under the interfaces. So if you want to see that group, you can do that. But if not, we can say no for that. So that way it just shows up as individual interfaces on the left, and we're not messing with the way that looks. And for description, we can call all private interfaces. Hit save. We're going to hit apply. So now let's go create rules with this group that we just created. Let's go see what this looks like. So let's go to the user interface under rules. We'll start with the user interface. And note, by default, there's no rules defined. So that means everything's going to be blocked by default. So let's go to add. So we're going to be creating 2 firewall rules. And this is the first firewall rule. It's going to allow access to the internet and block access to all local networks, because that's our purpose of creating the VLANs, is not just to separate our broadcast domain for if you have many devices in a network for performance reasons, but we also want to do it for security reasons, and we're going to have a firewall that blocks access between all of our different local networks so that they can be protected from one another if something gets infected, right, on your network. So notice we're on the user interface, is what we clicked on, right? When we added the rule, this is already filled out by default. And then for the TCP IP version, we're going to use both IPv4 and IPv6 because the alias that we're going to be using is going to have IP addresses for both protocols in it. So we can combine the rules so we don't need two separate rules. In some cases, we can do that. So for the protocol, we're going to say any because we want to allow TCP and UDP and those sorts of things. You can kind of limit this further if you need to allow specific traffic, but this is a good one to allow access to the internet. And for the source, we're going to use usernet. So let's type in user net, and this basically means any traffic coming in on the user network. That's our source. So we want to limit that down. So saying any, just to make it a little more restrictive. And for the destination, we're going to make use of that alias that was automatically generated when we created our firewall group over here on the left. So let's go to destination, and we're going to type in private. We're going to use the private net one, not the private networks. This is the example that we use for private networks that you can use if you're only worried about IPv4, or if you have static IPv6 addresses, you can make use of this alias since you know what all the addresses are going to be. But we're going to make use of the private net so we can take advantage of the dynamic IPv6 address alias here, okay? So let's pick private net, and you'll see it filled it in here. And we want to click on destination invert because this option is going to say allow up here at the top, right? We'll say we want to allow, which is pass. We're going to allow traffic from the user network to go anywhere where this destination is that's not in our private net address ranges. So this makes it the opposite because it inverts it. So we're basically saying allow any traffic not to private networks, which means the public internet. So the destination port, we're going to say any. Because we want to allow traffic to HTTPS and HTTP and various other protocols. You can limit this further if you so desire, but to be able to limit this, notice I can't select anything here. You're going to have to pick TCP or UDP right here, because right now it's grayed out because there's other protocols that do not have ports, such as ICMP. Okay, so that's why that was grayed out if you're curious. And we want to put a description in here that says allow access to the internet and block access to the local network. Okay, and this will give us our internet access that we want, and we'll just click save. Because we're blocking the private network addresses, it's going to block the user interface's IP address, which for this example would be 192.168.10.1 because it's in a private network address range. Because we just blanket blocked all of it, right, with this rule. So what we need to do is create an additional rule that is a pass rule on user, and we want IPv4 and 6 because we want to allow DNS on both. For protocol, let's pick UDP. Sometimes DNS can use TCP in some cases, but I think for the most part, especially unencrypted DNS that's going to be used on our internal network, UDP should be fine. And for the source, we're going to be using usernet, just like we were using before. But the destination is going to be user address because that's our interface IP address, because we need to allow DNS from the user network to access the user's interface IP address. So you see how these rules can be readable? And we want the destination port to be DNS, which is right here, a well-known port. So you don't even have to type anything in there. And then you could just say allow DNS on user network, right? You could just say on user network. All right, and then hit save. I typically like to have some of these interface rules at the top. You don't necessarily have to do that when you use this type of rule. I used to think it mattered, but it only matters if you split this rule out into two different rules where you block the private IP addresses and then allow all, then you definitely have to have this above the block rule. But since this is an allow rule, if it doesn't match this rule, it'll just drop down to this rule here and then allow it. If all your allow rules don't match anything, it's going to block by default. So if you just like to have it up here, we can just do this. We can move it by clicking this checkbox and clicking this arrow here, and it says move it before this rule. And that way you could have it like this. So this is going to be the minimal amount of rules we're going to have for each of our networks. If you want to have a completely isolated network, you could leave all the rules empty, and it'll devices within that network will still function. You just won't be able to access the internet or anything like that. And I use that for IP security cameras, and I basically allow my devices to reach into that network to view the camera feeds, but then nothing in that network can reach out to the internet. Okay, let's click apply changes. You don't really need to click apply changes till you're done with everything. So let's move on to the next network. All we have left is IoT and guest, and we'll circle back around to LAN and make it a little more restrictive because right now it's wide open. What we can do to make it quicker to update IoT and guest is you can clone the rules. There's a button over here that says clone. That way we don't have to type all this stuff out again, right? So it does save a little bit of time when you're first getting set up, or if you want to have a rule that's similar across different interfaces, we want to tweak a few things. So what we need to do is click on this clone button, and we're going to clone both of these rules. So let's just click this, and we're going to make sure we set it to, we're going to go do the IoT network next. So we just pick IoT, and then is the interface. And then when we go down to the source, we need to make sure they changed the way this box works. So let's go back to usernet at the bottom and uncheck it, because now you can check multiple aliases in here, which is cool because you couldn't do that before. But now we need to type in IoT and then type in IoT net, and then make sure only IoT net is the source, and then private net is the same, and then we can leave our description the same. See how that's a little bit quicker than filling everything out again. We just had to tweak two little things in there, right? And then it jumps us over to the IoT page, and we're good to go, right? So let's go back to user, and we can just clone the other rule, this DNS rule at the top, hit clone, and then we'll pick IoT as the interface, and then we'll make sure we pick the usernet again to uncheck it, and then we'll type in IoT, and then we'll check IoT net. And then we'll do the same thing down here. We'll type in user, we'll uncheck user address, and then we'll go to IoT address, right? So the pattern follows the same for these rules, okay? And then we'll just change this description to make it more reasonable here. All right. And then we'll do it again, the same process again for the guest network, right? So we'll do guest, and then make sure to go IoT net to uncheck it, and then we'll go to guest net, and then that's all we need for that one. Hit save. See, it jumped us over. We can go back to IoT, and then we can clone the DNS rule. If I'm moving a little bit fast, you can pause and go back, because it's the same process I'm doing for each one. So I'm just trying to do them a little bit quicker just to get through the video. But basically, we're just going to pick guest, and we're going to pick source. We're picking IoT to get rid of that. And then we'll pick guest and guest net. And then we'll do IoT, clear that out, guest network address. Okay. And then change our description, guest. All right. So now let's go to the LAN interface, and notice there's two different rules. They split out IPv4 and v6, but you could technically have this as IPv4 plus IPv6, and it would still work the same. They probably do this potentially because you can have different gateways and stuff if you want to tweak these default rules, but it also makes it easy to see this one's IPv4 and v6. So sometimes you have to split the IPv4 and v6 rules out separately, and sometimes you can combine them whenever possible. So what we're going to do for these, we'll just delete these two out, and you're not going to lose access because you have not only do you have the anti-lockout rule, but we haven't hit apply changes yet, right? So we'll just pick ones up from the user network, and we'll just clone them again, do the same thing. So we're just going to make it for the LAN interface. This will be our management interface, right? And then this will be, make sure we clear out the usernet, and then go to LAN net. And then we'll just go down here and hit save. And then we'll go to user, and we'll get the DNS rule. We'll clone that and get the LAN interface, and then we'll pick LAN net. We're going to make sure we clear out usernet first. And then we'll go to LAN net, and then clear out user address and add LAN address in its place. Okay. Oops, if I can type. All right. So if we go down, all right, we can move this one up to here just because we can, and we can finally hit apply changes. One thing I'll notice before continuing is there is this private rule group page here. This is for your private firewall group, right? So it gets its own little page where you can create firewall rules in here. I've seen some users group their interfaces and then do the isolation of the networks here, so you don't have to have any rules in the other interfaces, which does work if you want to block access between networks. But the problem is if you have a block rule in the group section, you can't override that in any of these interfaces below because group rules get processed first. It goes floating rules and then group rules, and then it goes to interface rules as the rule processing order. So if you block something in this group, you're either going to have to, and you want to allow something an exception, you're either going to have to add it above the block rule in this group level or add a floating rule. It kind of takes away the granularity that you have by specifying rules on individual interfaces. So I prefer to have these minimal set of firewall rules on each interface because it's not a lot. There's just two minimum that you have to have on each network. And then you can allow access or block access here. Now that I mentioned that, let's go to the diagnostics page and the alias section. I had to do this after I created a rule using the alias for the group, the private network group. You see this alias here? It's called private. It's like __private_ network. This is an alias that's automatically generated. That's our private net alias that is generated for our firewall group that we created. And you can see in here that it's going to have all the IPv4 addresses and also all of the IPv6 addresses here. And so this is why it makes it very useful to use that firewall group for dynamic IPv6 addresses, because it automatically pulls the proper addresses for each network in this alias. So that's why grouping them together in a firewall group is really nice for dynamic IPv6, and that's why I took that approach in this guide. Now we need to connect the management interface of the Proxmox system to the network switch. Next, I'm going to connect one of the Proxmox 10 gig interfaces to the network switch, and this is where I'm going to run all the apps and services for the network. So I just want to show real quick that I have Proxmox set up here with my GWN Manager. I'm calling it GWN Manager Demo, but I just have it running in an LXC. So that's just something I want to show. If you go to PVE Demo here, which is our Proxmox node, and go to Network, you'll be able to see that I have my management interface set up here on the management network, which is our .1 network. So I have as .1.5. But I have the second VBMR2 set up with a VLAN aware bridge so that I can assign any of these containers or VMs to a VLAN of my choice, so I can play around and experiment with apps and services on different networks. And so the GWN Manager, if I go to here and go to Network, you'll see that I have it on VBMR1, which is the management interface. If I come back to here, and you can see VBMR1 is this interface. If I want to have a speed test server on a different VLAN, I can go to Libre Speed and then click on this, and I can go to VBMR2, and I can just put a VLAN tag in here of like 10, 20, or 30 like for our different networks, and just hit save on that. Even though we're going to configure the network switch next, let's just go ahead and plug the access points in just so that we can see them show up in the GWN Manager, which we're logging into next. Each of the wireless access points has a PoE port, which you need to plug the Ethernet cable into, and they're labeled on the back side. And then we're going to make sure that the network switch is plugged into the patch panel so that your access points can get power, and they should be powering on once you plug it into the PoE switch. Next up, we're going to log into the GWN Manager that's hosted on the Proxmox server, and so we can configure the VLANs on these network switches to make sure that we have VLAN traffic passing between the switches in the Proxmox server, and between the two switches, and between the switch and the router, and the switch and the two access points. So now we're going to log into the GWN Manager so we can configure our network switches and then later our access points. So let's go in here and sign in. You'll see that I have two switches and two access points online. I already provisioned these devices and adopted them before this video so that we can see them here, so we can configure them quickly and easily. I want to mention before we get started here that the GWN 7821P is such a new switch that I had to get a patch from Grandstream to be able to adopt this device into the GWN Manager. So hopefully there'll be an update soon in the next couple months that will enable these new devices to be adopted by the GWN Manager. The great thing about Grandstream is you can still log into each individual device's web interface, even if you can't adopt the devices, which is one reason why I like Grandstream. So even if you have any problems adopting the devices, you can still go in there and configure it and use the device. You're not dead in the water like you would be for other devices that require adoption and or cloud only options. All right, so what I want to show here is if we go to settings and LAN, this is where we go and create all of our VLANs. I just want to show you that the default LAN is VLAN ID 1, and almost all network switches default to VLAN 1 as the ID for the untagged default network. So basically your managed switches by default will work as though they're an unmanaged network switch. So everything you plug in to this switch when you first get it will be like on the same network, but we're going to change that so we can separate our devices out in different networks, different VLANs. Okay, so I want to show you this, and then I'm going to jump down to profiles real quick because I want to show you what ends up being in this menu option. So if we go down to the port profile section, you'll see that there's a default LAN defined here as a profile, and this mimics the same LAN that's the default in the LAN settings. So it's a VLAN ID of 1 and 1, so it automatically creates this. It also automatically creates a all VLANs port profile, which whenever you create additional VLANs, it will include everything in there automatically. So this is handy if you want to allow all the VLANs to cross trunk ports, for between all your devices of your network switch. We'll actually make use of this all VLANs port profile in addition to the default LAN port profile. And by default, whenever we create a VLAN, I'll show you in a little bit, anytime we create a VLAN, it'll automatically create a port profile for each VLAN in here. Okay, so that's what will show up in your dropdowns when you assign VLANs to ports. In addition to these default profiles, you can click the Add Profile button, and you can add a port profile of your own choice. And this becomes more useful when you have multiple VLANs, and let's say you don't want all the VLANs to cross between different devices, or you have special settings you want on certain ports, such as like the duplex mode, flow control. You might want to have some security options down here like port isolation and that kind of thing. And the nice thing about this is if you assign multiple ports, these settings, whenever you want to change all those ports at the same time, you can just say you want to enable port STP, for example. If you click this, then all the ports that are assigned this port profile will automatically be updated. So this is a great way to change multiple ports very quickly. So let's go back to the LAN section here. And one thing we want to change with the default LAN, it's not necessarily critical to do this, but I just like to do just to make it consistent with my other VLANs, is you can set it to VLAN only network. And what this means is it's not going to assign anything with the DHCP server. And by default, it's blank. So if you leave the default LAN as it is, it's not going to assign DHCP or anything like that. Since we're controlling our DHCP from our OPNsense machine, we don't need any DHCP server settings or any of that sort of thing. So we just want to make this VLAN only, and we'll have OPNsense be the DHCP and DNS provider, and not in the network switch itself. Okay, so we'll just go ahead and hit VLAN only network, and we'll click save. So at this point, we can create our 3 VLANs that we also created in OPNsense. So we'll just hit add, and this will be pretty simple. We'll just give it a name. So we'll do user, and this is VLAN ID of 10, and we're going to do VLAN only network. You see how simple it is? We're just to create a VLAN. We'll just keep doing this. And we'll do guest, and we'll do VLAN 20, and then we'll just say VLAN only. One more, we'll click add, and we'll do IoT. So we're just mimicking what we did in OPNsense, but we're doing it for the network switches, because the network switches and their wireless access points, all those things need to have those same VLAN IDs. Okay, so once they all match up, that's how you assign everything to the proper networks. So as you can see here, we got our 3 VLANs that we've added. There's also some additional global settings you can set here if you want something, these things to apply to all your network switches, but we're not going to mess with any of these things for the purpose of our demonstration here. Okay, so let's go to the profiles again. I want to show you that it automatically created our port profiles for each of our VLANs. You'll see that the native VLAN and the allowed VLAN is the same, which just means only the VLAN that you are assigning is the only VLAN ID that's allowed, and that's also the native VLAN. So that's basically meaning any device that's plugged into that port, the native VLAN is going to be 30, and it's only going to allow ID of 30, right, for the IoT network, which is exactly what we want for our devices to be on a single network. And you'll notice the all VLAN still has this like dash here, but it does default to all the VLANs. This is just a special created one automatically. You can't edit any of these. And we can't edit any of these ones either. The only ones that we can edit is if we go to add profile. And I want to show real quick, if we just call this, let's say trunk port or whatever, and we could say which one was the native VLAN, which if you want to use your default LAN for untagged traffic, you can still do like, okay, let's only allow user and guest on here and not IoT. Then we can just hit save, and you'll see that the allowed VLANs is 1, 10, and 20. All right, and so this is how we can restrict which VLANs get across to different devices, because you might not want all of the VLANs necessarily to go to all devices. A little bit better for security as well if we don't allow any extra VLANs across if we don't need them. But see how on this is a custom profile, so we have the ability to edit and delete it. So let's go ahead and delete it because we're not going to be using that. Okay, let's go over to devices. So at this point, we can go ahead and configure our network switches to assign all the ports to the proper VLANs. So let's start with the 7821P. And this we'll go to port. And this gives you a nice visual of all the ports that are on our network switch, and so we can assign them to various port profiles and other settings. And what's interesting about this network switch, because it's so new, the color coding isn't correct for the 2.5 gigabit interfaces. It's correct if you log into the web interface of the network switch, but in the GWN Manager, it's not updated yet to handle these newer network switches that have 2.5 gigabit Ethernet interfaces. So the ones here that say they're like less than 100, like 100 megabits or less, these are actually my 2.5 gig interfaces. And this one's supposed to be 2.5 gig as well, but I switched to a different PC for this demonstration because I had to re-record this section. I had a little bit of a disaster, but I am re-recording this to show you how this works. And then these are our 10 gig interfaces, so they actually light up properly as 10 gigabits. So now we need to click on the ports that we want to assign to our default LAN, which is our management VLAN. And so that is going to be port 1, which is our PC. And port 7 is the LAN interface connected to OPNsense. And port 8, which is our management interface for Proxmox server. So, and then we're going to pick the port profile of default LAN, and we'll click save. Next, we're going to click on all the devices that need access to all of the VLAN traffic so that we can assign them to different networks. So, for example, ports 3 and 5 are the two wireless access points. They need to have all the VLAN tags pass through so that we can assign different wireless networks to different VLANs. And then port 9 is our Proxmox system that we need to allow VLAN traffic through it so that we can assign various containers and apps to different networks for testing or hosting various services. And then port 10 is connected to our other network switch, which is our GWN 7832, our 10 gigabit switch. So we want to have all the VLAN traffic to pass through between the switches. Okay, so now we need to pick the port profile, which is already set to all VLANs by default. It just kind of defaults to that. So we just hit save. And finally, for these ports up here that we're not using, ports 2, 4, and 6, we want to assign these to the guest network because we don't want to allow any of these extra ports to be assigned to our management network, because by default it's going to be sitting on our management network. This is where if you had a dedicated management network, you wouldn't necessarily need to do this because you wouldn't be using the default LAN. But this is where I also mentioned that for a small network, it's easy enough just to assign these 3 to another network. And then we know if somebody plugs into these, if you have this connected to various wall jacks in your house or whatever, that you don't have to worry about people getting onto your management network. So it's kind of a little extra security here. And so we'll just go ahead and assign those. All right, so now let's jump over to the GWN 7832, which is our 10 gigabit switch. We only need to configure a couple ports on these because we're only using 2 ports. But if you click on the port section, just like the others, so you can see we have port 10 and 12 being used. Port 10 is where our other network switch is connected. And port 12 is our 10 gigabit interface that's connected to OPNsense. So let's go ahead and click on 10 and 12. And we're going to assign these to all VLANs, and which is already set to by default. And we'll click save. And for all of the other interfaces, just like we did on the other network switch, we're going to assign these to the guest network just to make sure we don't allow anybody on our management network unless we say so, right? So we'll go ahead and assign this to guest. And just like that, we don't have to worry about any devices that aren't supposed to be on our management network, okay? So that's all we really need to do to assign VLANs to our network switches. As you can see, it's a pretty simple process. Some network switches require you to edit the PVID in a separate place in addition to assigning it to the proper VLAN. And a lot of newer switches, seems like you just assign the port and you're done. You don't have to do this like two-step process. So that makes it very convenient and easy, and it makes it less likely to mess up, because when I had TP-Link switches, I had to edit things in two places, and then I would get confused and forget about it, and then wonder why my VLANs aren't working. But this is a lot easier to be able to manage. So while we're still in GWN Manager, we're going to configure the wireless access points. We'll get the SSID set up and the configuration for the wireless access points. The wireless access point configuration is an area where I can show you some basic settings, but you might have to play around with some of them depending on the environment where you're deploying these wireless access points. You may need to tweak some values a little bit more. It's not like a concrete thing where I say you have to pick these things, because if you have an area where it's difficult to get a signal, and depending on how far you have them spread out, you might need to tweak some things to get optimal performance, because wireless is not the same as having these wired connections, right? You're going to have to play around and know your environment well. So now we're going to configure the wireless access point settings. I'm going to be creating an SSID per VLAN. So while we're creating 3 SSIDs, you probably don't want to create more than 3 or 4 SSIDs, because that could potentially be problematic. You'd be saturating more of your radio bandwidth that's available, and if you have a bunch of neighbors with Wi-Fi routers and access points nearby, it's already going to be crowded and congested. You can use a single SSID with PPSK and have different VLANs assigned to different passwords of devices that are logged in. That's one potential option to minimize the radio interference. But I read that some wireless access points have degraded performance if you do PPSK. I'm not sure if that affects Grandstream as much, but I'll have to try that out and see, because I might consider doing something like that in my network, just so that I don't have to have like 3 or 4 different SSIDs broadcasting. I can just have a single one, and then based on the password, I can assign different VLANs. But I'm not going to demonstrate that in this video, because I think creating separate SSIDs per VLAN is a pretty straightforward way of going about it. And it allows you to apply different settings to different radios and different SSIDs and that kind of thing. So you have maybe a little more flexibility in how you configure your Wi-Fi networks if you use separate SSIDs. So there's some advantages and disadvantages to different approaches. What I'm going to do is click on the Wi-Fi settings here, and you're going to see there's a GWN Manager wireless network already created by default, and it's already enabled. So you already get this out of the box. But I'm going to be editing this default network because we're not going to be using that. And I'll be creating 3 different networks, but we'll just edit the first one here. Let's click on edit. And we'll create one called HNG user for our user network. And we want to make sure this client IP is set to bridge and not NAT, because otherwise your wireless clients will be behind a NAT, which is behind your normal router. So you kind of be double natting your clients on your network. Some people might like that extra isolation for whatever reason, but I like just being able to have the clients being on the network exactly the same as wired devices. So that's where bridge mode is the best option here. And then you can set an associated VLAN, which we're going to set it to user. And this is how we set our VLAN ID. So it's pretty simple. And this is where you can enable captive port over here with this option if you want that on your guest network. I'm not going to show setting that up, but there's an option there for that. So for access security, this is where we set our different WPA modes. For best compatibility, you could use WPA2. You can also do WPA2/3, so newer devices will hopefully default to 3. I haven't tested out to see if devices do a good job at defaulting to WPA3 or not. Just keep in mind, if you switch to WPA3 only, some older and more legacy devices may not support WPA3. It's just something to keep in mind with that. I'm just going to leave it as WPA2 just for maximum compatibility. I'm going to set my own password here because it defaults to one that's written on the back of the wireless access point. All right, and then we can leave the rest of these settings the same. We don't really need anything under access control. This is if you're going to have your clients to be isolated from each other. You might want to do that on your guest network, because if you pick this, then you can say you want the radio to be isolated, or internet, or gateway. There's some different options here, and you can read about what they mean here in this tooltip. So I'm not gonna be worrying about that. And there's some bandwidth control options. Okay. And now down here for the device assignment, we want to make sure that both of our wireless access points are enabled here. If you check this box, I think if you add a new wireless access point, it would automatically assign this SSID to that new device. But otherwise, if you only have these checked like this, if you add a third device, you might have to manually go back and add it in as a device that you want to have this SSID on. So for most home users, you probably want your SSID on all of your wireless access points. I'm not quite sure if that will allow it for future devices, but it doesn't hurt to check it. And then there's some advanced options if you want your SSID hidden. The only one I would probably recommend changing here for the most part would be the DTIM period, DTIM. To set it to 3, I read that this works well for mobile devices to increase battery life because you get a little bit less, I think, different messages or beacons that are sent to your phone, so you're not waking your phone up a lot, getting or receiving a lot of messages. So that's kind of like a little power savings tip there that I have found online. And you can decide if you want multicast and stuff like that enabled on your wireless network. It's enabled by default because this is an option to suppress it. So if you enable it, you're suppressing it. You might want to enable 802.11.r to help with roaming between different wireless access points. I've read, sometimes there's like tips on like older devices that don't support it. It might potentially hinder things, but I think most newer devices may support that. This is one of those options you can play with to see if it helps with anything. This Bonjour gateway might be something interesting here. It'll forward Bonjour messages, which is like discoverability of various media server devices and stuff like that. You may want to enable that if you have any wireless devices that you want to discover across your networks. You might want to make sure you enable this because it might automatically forward it across. This may or may not be necessary if we have it enabled in OPNsense. If you install the plugin in OPNsense and you pick which VLANs you want to forward that traffic. Not sure if you need it also on here on your wireless access point or not. If OPNsense is handling it at the router level, you might not necessarily need that, but that's an option here that you could play around with if you're having some issues with discoverability. This option is enabled by default. This is like a power savings feature for your clients that are connecting to this wireless access point. I don't think it's a power saving for the wireless access point itself, but for devices connecting to it, maybe it gets a little bit less messages or something like that. If this is interfering with any of your devices, you may need to disable that. So let's go ahead and click save. And for these other ones, we're going to add them a lot quicker because it's just the same process. We're going to click this to enable it. And then we're going to enter the next one, which is going to be guest network bridge. We're going to do associated VLAN, and then we're going to click on guest. And then we're going to go access security. And then we're going to type in our key and make sure our device assignment is set to all devices, which it looks like it is by default. And see, this one had it checked by default, but whereas the other one didn't on the default network we had set up. And in the advanced, we can go ahead and put this as DTIM period here. We can enable 802.11r. Let's go ahead and click save. And then we'll add our final SSID for the IoT network. Make sure we enable it. IoT. And then associated VLAN, which is going to be our IoT network. Okay, then we click on access security, type in our password. Make sure our device assignment's good. Looks like it is. And then advanced, we can set this to 3 and 802.11r and click save. All right, so now we have all of our SSID set up, and we probably want to go here next to the global radio settings. This is where we can set some settings that apply to all of our wireless access points. Band steering is one if you want to try to encourage your devices to connect to 5G or 6 gigahertz or 5 gigahertz instead of defaulting to like something slower like 2.4 gigahertz. So you may want to enable the 5 gigahertz on priority to make sure your clients are getting the maximum speed. This may or may not be a good idea to do it for all your devices. Maybe the IoT devices, you might want to just let it be on the 2.4 gigahertz or whatever. You have to experiment with some of these type of things. You can do some client steering if you want to encourage devices to disconnect off one AP and join another one based off this threshold. And I've seen some people study this option in detail for other products like Unify, and decided that maybe it's not the best idea to force the things off and just let the clients decide on their own when it's a good time to jump to another access point, because they might be able to make better decisions than us forcing in a hard-coded value here, because depending on the various environmental conditions for our access points. So I'm going to leave that off. Airtime fairness is if you have a lot of clients and you don't want a couple of clients hogging all of your network bandwidth, it'll probably kind of ensures that everything gets balanced better. This is more for high traffic networks. You may want to do this if you have a lot of IoT devices, potentially. Not sure if you really need that. For home networks, you probably want your fastest devices to be able to use the maximum throughput so they can just do what it needs to do and get done. It doesn't matter about the fairness as much, I feel like, for home networks, unless you have a ton of IoT devices, maybe. Okay. And then down here for 2.4 gigahertz, you can assign a channel width. 2.4 gigahertz is so crowded, it's generally recommended to enable 20 megahertz instead of 40, just because you're going to get more interference with 40 megahertz and there's less channels available, especially if we're running multiple SSIDs. 20 is probably the best bet here. And so, you might not get that much more performance with 40 if you have a lot of interference. If you're like in a more rural area and you don't have a lot of wireless around you, you can go ahead and enable this maximum throughput here. If you set this to automatic, it may adjust itself on occasion if it finds there's other channels that are more available. For radio power for 2.4 gigahertz, you might want to set this to like medium, just so you're not like flooding out, devices around you, and be respectful for everybody that's around you. And it still could reach pretty far, I imagine. A lot of times that's what I like to do for 2.4. I put it on medium, just so my network isn't broadcasting all the way down to my neighborhood, or whatever. And I can still get the reach that I need with medium. And with all the 2.4 gigahertz devices that are out there with Bluetooth, and if you're doing Zigbee or Thread and all these different, smart home technologies are using 2.4 gigahertz, it's probably better not to like crowd out that, flood it out with too strong of a signal here. You can decide if you want to allow legacy devices or not, because if you have slow devices connecting to your wireless access points, it's going to slow down your other devices. All right, so for 5 gigahertz is very similar. You can go to 80 megahertz or 160. You have to experiment if you're going to get that much benefit from 160 megahertz or not, depending on how crowded your 5 gigahertz channel is, because it's starting to get more crowded, even though maybe not as crowded as 2.4 gigahertz. That's why they have 6 gigahertz now as well. None of my access points have 6 gigahertz, so I'm not worried about the settings on this right now in this demonstration. But we could try the 160 megahertz to get the maximum throughput, and we can leave this on auto. For radio power for the 5 and 6 gigahertz, I usually like to leave it on high because it helps penetrate walls a little bit better. And I think the client still can connect back to the access point reasonably well. Haven't had too many issues with that. So we can click save on this section. And then there's also a mesh section down here if you want to mesh your APs. I believe all of the Grandstream APs can do meshing, which is great that they offer that ability. If you have a spot that's really difficult to get a wire to, or just don't want to take the effort or time to do it, you can do that meshing. It does reduce the number of SSIDs that you can use because it has to use some of those radios to mesh between the devices. I'm not sure how well that performance works on those, but it's good to know that you can do that if you need that ability. So basically, this is all you need to do to set up your 3 VLANs and your 3 SSIDs. Not too difficult. There's a lot of different settings you can tweak for the wireless, but those are things that you can leave mostly at the default, and you can just tweak a little bit of things here and there as you want to play around with and try to improve performance and optimize your wireless, because there's a lot more to getting wireless fine-tuned than it is with wired connections. So that's something that I'll leave up as an exercise for you to do, but this should allow you to at least get up and running with your wireless on your networks. So now that we have all this configured, you can log into the different SSIDs and make sure you get the proper IP address assigned to each network. And you can check your phone settings or your mobile device settings to see what IP address you're configured at. And you should be able to access the internet on each one of these devices. So that's also a dead giveaway. If you can get an address and you can access the internet, you probably have everything configured properly. You can do some tests to make sure you can't communicate between the networks. All right, with everything set up, what we're going to do real quick is do a quick sanity check on all of the different VLANs just to make sure we got all of our configuration in OPNsense correct. We don't really need to check the LAN interface because we're already on that interface, which is nice because we already know we're then I'm connected to port 1, it's on default LAN. So for, let's just say port 2, we configured all these to be guests because they're not being used, but for temporarily, we're just going to set one of them to user, and then we'll hit save, and then we're going to make one of these IoT, and we'll leave the other one guest. And I'll plug my PC into each one of these, and we'll see if we get an IP address in each network. That's one way you can quickly test if everything's working properly, because you're going to get an IP address in the proper VLAN IP address range that you have configured. Right now I'm in the LAN network, which I'll show you, which we obviously are in the management interface. So you can see I have a .1 IP address, .1.139. So now I'm going to plug into port 2, and we'll see that this will change to, should be .10 something else. Let's see. All right, I plugged into the port 2. All right, so I'm going to do IPA. And you can see I got an IP address of 192.168.10.103, so that worked. So now I'm going to move it over to the next port, port 4, and we'll see what we get. All right, so I plugged into port 4 IoT and it didn't work, and so I plugged back into my default LAN, which is my management network, and I looked and I didn't have DHCP enabled. So this is why we test things out. It's easy to forget to check this box, so we need to make sure we do that, and we'll hit save. That's something we want to make sure we don't forget. So that's why we double check our work at the end, right? So let's try this again. Plug in a port 4. All right, so let's do IPA. And you can see I have .30.100. So I didn't have my DHCP server enabled. So now that it's enabled for that VLAN, it works. So that's beautiful. Then we got one left. We got port 6 to try. All right, let's see what IP address we have here. And we have .20. So now we have all of our VLANs working properly for our wired connections, and then you can repeat this process with the wireless networks as well. So let's go ahead and check those. Let's see, I'm connected to the wireless user network, so I got a .10 address, so that works. So let's connect to, you can see I'm connected to wireless on here. You can see I'm connected to the IoT network at the bottom here, wireless. So let's do IPA. You can see I have an address of .30, and notice it's 101. When I did the wire connection, it was 100, so I got a different IP address for this wireless connection. All right, so now we're on the guest network. So this is our final one to test of our wireless. So we do IPA, and then you see we're .20. So we tested the VLANs for all the wired connections, and we tested them for the wireless connections to make sure all the VLANs are working properly. So I'm going to show a speed test routing across 2 different VLANs on that same 10 gigabit SFP Plus interface to show you what kind of speeds you could potentially expect. And there's probably some other performance tweaks that you can enable as well, because I didn't enable RSS or any of those types of things. But as you can see, I'm getting close to 8 gigabits per second, which is pretty good. I'm running this on the Atom C3758 CPU. It's possible that could be a little bit slow, and it's on a virtualization LXC container that I'm running this, not bare metal, and there's some other factors involved here, right, as well. So, but I feel like it's still pretty good. It gets you close to 10 gigabits. I just wanted to kind of show that you might not quite get 10 gigabits depending on how you have it configured, but you should be able to get relatively close, because routing doesn't require like a ton of CPU, but when you start adding in IDS and IPS and other things like that, it's gonna take your throughput even further down. So this kind of gives you a rough idea what you can expect from an N100 system that I've built with a 10 gigabit Ethernet interface. I know that if you use the N100 as just purely as a desktop client, you can easily get 10 gigabits with this hardware. But when you start throwing in routing in the mix and some other factors without tuning, OPNsense, you're going to potentially not get that full 10 gigabits. So congratulations, you now should hopefully have a full network constructed. And at this point, I'm going to circle back around a little bit and show you a couple little more things that you can configure in OPNsense that you might want to do once you get the full network set up and things are working properly. We're going to go over to System and Settings. We're going to be doing several things in here. Let's go to Miscellaneous. And if you go into here for the hardware for thermal sensors, I think it's nice to show the thermal sensors. If you're using, say, Intel hardware, I just pick Intel Core. So PowerD is a useful option you might want to consider because it helps save power, especially if you're running bare metal. I'm not sure if this will help any at all if you're running virtualized. So high adaptive is probably a good option where if you prefer performance over power saving. So it's going to ramp the CPU up faster, but trail off slower to idle, before idles. And then it keeps the load lower because it's processing things faster. So you can see this, what it says here, raises frequency faster, drops CPU slower, and it keeps twice lower CPU load. Minimize that. Some of these settings down here for disk and memory settings are useful because you can write stuff to memory instead of to a disk, and this will save on writes on your disk. So if you're using storage that's very write sensitive and it's going to wear out your drives quickly, you can write some of that data to memory, like your log files and your temp space. But you have to keep in mind, if your system shuts down or you restart, it clears out every time, right? So if you don't care about that sort of thing and you don't need to have logs between reboots, you can save wear and tear on your drives by enabling some of these options here. And if you have a system like Protectly, like I've shown before on my channel, you can disable or enable to shut down beep sound. So if you have a PC speaker in your system, you can disable that if you don't really like that sound. But I kind of like that little beep sound because I can hear it from my server closet when I'm rebooting. So I kind of like that little tune that it plays. It's pretty nice. So let's hit save on this. And now that we enabled the thermal sensors, let's go back to lobby real quick in dashboard. And then we can go up here and I'll show you if you hit edit dashboard. Actually, you can hit add widget instead. We're going to go down to thermal sensors and we'll click add, and boom, there's the thermal sensors there. You gotta make sure you hit save at the top, but you can move it around first where you want it to go. So if I want to put it under here, I can drop it right there if I want, and then I can just hit like save. So next thing we're going to do, if we go to system settings, tunables, you can find the setting for HWIBRS _ disable. So this one right here is a Spectre version 2 mitigation for the CPU. Right now it is set to 0, but you might want to set this to 1 to disable it, because right now it's enabled. Because this type of CPU vulnerability is more important on cloud computing environments where you have a lot of shared users on the same system that are potentially untrusted users. Whereas a firewall, you're not going to be having untrusted users running on the system. Plus, some of these CPU vulnerabilities have only really been demonstrated in a lab environment. I don't think a lot of these have really been shown to be demonstrated out in the wild. You can get some extra performance if you enable this to 1, and this is a runtime value, which means we don't have to reboot the system if we hit apply on this. There are some people that say pfSense is faster than OPNsense, and partially it's because OPNsense defaults to having this enabled by default for security, maximum security, and it favors it over performance, but you can get that performance back by tweaking some of these tunables. So that's one little option there I wanted to show you as something you could do. So let's go to administration under settings. You might want to enable HTTP strict transport security to get a little more security for session hijacking and that sort of thing. I believe for the OPNsense web UI, you can enable that. Let's go down to listen interfaces. This is where the web UI for OPNsense listens on, and it recommends doing all interfaces. So you can access the OPNsense web UI from every interface on your network for all VLANs, assuming the firewall rules aren't blocking it. And the way that I wrote the firewall rules, it's going to block HTTP access on your interface IP address by default because of the way I wrote the rules. And that's why I had to allow DNS on the firewall rules, if you recall. I would have to do the same thing to allow access to the OPNsense web UI if I'm not on the LAN interface, because the LAN interface has an anti-lockout rule, so it can still get in. But for the other interfaces, I have to allow OPNsense, the web UI, port 443, to be able to get into it. I wanted to mention this. This is something I'm going to start recommending, because I used to say, come in here and make us your management network, and then it says, oh, and it shows you this warning, I know what I'm doing. And I want to say use the default, because I didn't realize this, but someone pointed out there are some very specific cases where if you don't listen to all interfaces and you bind to a specific interface, you're going to somehow not be able to access your web UI from the interface. It might have to do with like IPv6 in certain circumstances or something. I recommend just leaving it like this, because I don't want you guys to, it works for me, but then you go to do it and it doesn't work for you because you're doing your network differently. And so I want to make sure this works for everybody. And then secure shell, we're going to come down here, want to enable that. So most likely you probably want to allow access to OPNsense through a different way. In case you can't get to the web UI, you can always log in and then play around with the configuration and the settings without needing web access, okay? Because sometimes you have to restart something or you get yourself into trouble. So I recommend enabling secure shell. If you want to permit user login, I recommend don't enabling password login, but you can go in and add a key, and I'll show you where to do that. So we'll say permit user login for an example here I'm going to show. And just the same as with the web interfaces, allow recommended interfaces here, but and then you just control access through firewall rules. Okay, so we'll just leave this here to make sure we don't get in trouble with not being able to access anything. And this is if you're going to use serial console, you can enable that. It should be enabled by default. If you use the VGA console image that you installed with, it automatically has it enabled by default. So we can click save on this. It's going to reload the web UI because we made a few changes in here. All right, so if you go up to access and go to users, this is where if you go to edit the user for the root user, if you scroll down to authorized keys, this is where you can drop your SSH key in for the root user. So that way you don't have to use passwords. You just generate a key in your SSH client, and you can say these are the authorized keys that are allowed to use that root user. Alternatively, you can create your own user by clicking add, and then you can just make up a username, such as home network guy, and then you can give it a password. And then you can fill out some of the stuff if you want or whatever in here, right? And then you can just go down to login shell. You want to make sure you have the shell enabled down here if you want to have some shell access for SSH. So we can do bin/sh. And group membership, you can make it a part of the admin group, so you can have admin privileges. And you probably want to do all pages if you're an admin. Although if you're an admin, you might automatically get this, but it doesn't hurt to select all pages just to make sure that you can get access. And then you can do an SSH key for that user as well. And then you can click save. And then now you have another admin user that you can log in with SSH. What we could do now, if we want, we could just log out real quick, go to lobby, log out, and we could try our new user and see if it works. And you see we have access to the dashboard. It's really easy to create a new user, as you can see in the user section here. Once you have your new admin user set up, you could even go in and edit this user. When you're signed in as a different admin account, note that you can actually disable the root user from accessing the web interface. You're not disabling the root user for the entire system, but just the web access with the root user. So that makes your web interface a little more secure potentially, because you're not using the default root user, which has all permissions. Even though your new user has a lot of the same permissions, it's not the same as the root user because it has ultimate authority over your system. Whereas your admin user just has admin authority, which might be a little bit more restricted than the root user. So finally, we can go to services, unbound DNS, and go to DNS over TLS. And you can go here and click add. If you want to add Cloudflare as a DNS over TLS provider, you could say 1.1.1. And the server port is 853 as a default. All right, for verify CN, this is important to have. This is going to be cloudflare-dns.com for Cloudflare. But you'll need to find out what the verify CN domain name is, because that's how it validates the DNS over TLS request to make sure it's not being spoofed or anything like that. And you can give it a name and hit save. You have to create one for IPv4 and one for IPv6. And you can also do one for primary and secondary. So you should do 2 of each is ideal, is what you would like to do, to make sure that you have a fallback in case the primary one's down. It can fall back to the secondary one. And you can even be 2 different providers. It doesn't have to be both Cloudflare. It could be Cloudflare and Quad9. It could be NextDNS or whatever. You just click hit save and make sure it's enabled. I have query forwarding enabled, so that's why it shows this right now. But you wouldn't normally have this box checked. But I'm doing that because that's how I'm accessing the internet from behind an existing router. This is just a couple basic things that you can change. There's a lot more stuff you could get into with OPNsense and configuring and tweaking and learning over time. And now that you have the full network set up, you should be able to go in and start playing around with some of these additional settings and learning more about them, and more plugins and different things that you can really expand way beyond this. This is just the beginning. So I hope you found this guide helpful in creating a full network build using OPNsense. I'm sure there might be some questions if you're new at this, so I try to answer as many as I can, and sometimes I have to kind of stop answering questions just so I can create more content. So I only get to do this like kind of late at night. It's almost midnight right now, trying to film this. So I'm trying to stay awake and alert. I hope you guys stay tuned, even though it takes me a couple weeks to a month sometimes to get a video out, but I try to keep it going. So until next time, I'm Dustin Casto, and I'll see you in the next video.